everyone, here's a quick video on real-world applications for logs. Unlike all my other videos, I decided to start this one up with a warm-up. So we're going to find the inverse of y equals 6 plus 5 to the 2x plus 1. So just like any other time that we're solving for an inverse, the first thing that we have to do is flip our x and our y. So we're going to get x equals 6 plus 5 to the 2y plus 1. Okay, when you solve these, the first thing you want to do is get the exponential by itself. So in order to do that, I have to get rid of the 6. So I'm going to subtract 6 from both sides. So that will cancel that one out. So I get x minus 6 is equal to 5 to the 2y plus 1. Alright, now as we know, since our exponential is by itself, to undo an exponential or find its inverse, we have to do the log. So we have log base 5 of x minus 6, make sure you use parentheses, equals 2y plus 1. Okay, if it was only a y, we would be done, but it's not. So now we have to solve for y. The first thing we're going to do is subtract 1 from both sides. Okay, so I'm going to move over to the right side of the screen. So I have log base 5 of x minus 6 minus 1 is now equal to 2y. Alright, very last step now is just to divide by 2. So I get y is equal to log base 5 of x minus 6 minus 1 all divided by 2. And since y is by itself, let's put an inverse on it and box our answer. Okay? If you need help with this, just feel free to just make up your own numbers. You can choose any and every single number out there in the world and just solve it. As long as you can go from an log to inverse or log to exponential, you should be fine. Okay, first example for real-world applications. We have loudness L is measured in decibels according to the equation L is equal to 10 times log base 10 of R, where R is the relative intensity of the sound. Find the relative intensity of the firework display with a loudness of 130 decibels by solving the equation 130 equals 10 times log base 10 of R. Now the cool thing about log that y'all need to remember is that if it doesn't have the base at all, then it's automatically base 10. So the 10 does not have to be there. So whenever I write this, I'm not going to write the 10, just so you can see it both ways. Okay, so they were really nice and gave us the equation already. So I have 130 equals 10 times the log of R. Now in order to solve for the log of R, I have to get rid of that 10 in front. So I'm going to divide both sides by 10. Now 130 divided by 10, that equals 13. So 13 equals log of R. Alright, lastly, to get our argument, we have to take our log and convert it to an exponential. So as we said before, log without a base is automatically base 10. So I'm going to have 10, my exponent is 13, and that's equal to R. So R equals 10 to the 13. That is my answer. Okay, if I went too fast, go ahead and pause it, rewind, and watch. Alright, next one. It's asking another way to solve this using our graph. So the cool thing and easy way that y'all could do this is you could take one side of your equation, so 10 times log base 10 of R, and let's plug that into y1. And then you could take the other part and plug that into y2. And when you do that, you can look at your graph, and your graph will look something once my pen's not writing very well. I'm so sorry. That looks really ugly. Here we go. Eraser. This is really awkward. Okay. Great. Pen. Alright. Our graph will look something kind of sort of like this. This is a really rough sketch. Okay, and then as we've said before, your solution is where the two lines intersect. So right here. Okay, so that's just like every other thing that we've done. So you can always graph it and look at that. All right, our next example. The population of Odessa, Texas is 14,000 and is declining at a rate of 6% per year. So what that means is that 6% of their population is either dying or they're moving out. Use the formula P equals 14,000 times 0.94 to the T, where P is the population in T years from now, to find what the population will likely be in 20 years. Okay, so the 0.94, that comes from 100% minus 6%, 94, and it's as a decimal. All right, so we're looking for P. That's our question. So P equals question mark. And then we have our T. T equals 20. So literally all you have to do is plug it in. So we have P is equal to 14,000 times 0.94 to the 20. Let's type that into our calculator. Let's see, we got 14,000 parenthesis 0.94 caret 20, hit enter. Okay, we get 4061, so 4061.5. Okay, so for this we have to round down, and the reason for that is that half a person can't stay while the other half of that exact same person leaves. So we're assuming that this half right here, the whole thing, that whole person goes away. So that means we have 4,061 people left. And that is our answer. Okay, if I went too fast, slow it down, rewind it, watch it. All right, using the exact same scenario. So based on the formula, P equals 14,000 times 0.94 to the T, in how many years would the population become half its current size? Okay, so if we know the population, we want it to be half its current size. Its current size is 14,000. Okay, then you divide it by 2, so you get 7,000. So when you set up your equation, because we're looking for T, we're going to have 7,000 equals 14,000 times 0.94 to the T. Now, you want to get the exponential by itself. So you're going to divide both sides by 14,000. And then 7,000 divided by 14,000 is a half. And this equals 0.94 to the T. Okay, and so we want our population to be half its current size. So that's why this right here is a half. So if you want to start right here, that's fine. All right, now in order to solve for that T, we have to convert it to log form. So I'm going to have T is equal to, once my pen will write, because it's not liking me right now. T is equal to, we have log, our base is 0.94, our argument is 0.5, so a half. Now we're going to type that into our calculator, so hit math out of math, and type it just like you see it. So 0.94 and 0.5, hit enter, and you get 11.2 years. So in 11.2 years, their population will be half of its current size. Okay, now we're going to go into talking about PERT, where A is equal to PE to the RT. A is the total amount with interest, P is the principal, or the amount that you start with, E is a number. So E is actually above your natural log button, your LN button on your calculator. R is your rate in decimal form. So say they give you a percentage, you take the percentage and then divide it by 100, and that's your R. Okay? Put another line for an equal sign, but it's not. There we go. All right, T is your time in years. Besides that, we only use this for compounded continuously. And instead of using log, we're now going to use natural log. And natural log has a natural base of E. So make sure you know that. All right, our first example, if $10,000 is deposited into an account which pays 2% interest compounded continuously, How much has accumulated after 10 years? Use the formula A equals PE to the RT. Alright, so we're starting with $10,000. That's our P. So T is 10, or P is 10,000. Our rate is 2%. Divide that by 100. That's equal to 0.02. And then our T is 10. Okay, so we're looking for A. So I'm going to take this, I'm literally just going to plug this in. So A is equal to 10,000 times E to the 0.2 times 10. And we get, let's try it out. So I'm going to type in 10,000. I'm going to hit second ln, so second natural log, 0.2 times 10. Oh, sorry, that should be 0.02. That is my bad, guys. So 0.02 times 10. Let me fix that real quick on so that y'all can see that change where I messed up because I didn't fully pay attention. There we go. Okay, get my pen back. So 0.02 times 10. Okay, then hit enter, and you get $12,214.03. So with interest, you'll then have $12,214.03 in your bank account. Okay, if at any point this went too fast for you, go ahead, rewatch it. If you have any questions, feel free to ask your teachers. I'm here to help too, so hope this helps. Have a great day.